Hi, welcome. I'm Chris. So today we're going to look at monads. There's a simple takeaway from this that I want you to remember, if you remember nothing else from the talk, and it is this, that monads are an ordinary data type. Like you're used to working with strings or numbers or booleans, they all have their quirks, they all have ways in which you use them and functions with which you use them. But monads are just an ordinary data type. You're probably even already using them. Now, a lot of talks about monads are by functional programmers who are superior to every other programmer except at explaining what they do. And the trouble is that monads are explained using really complex terminology that doesn't really illuminate what they are. Sometimes they'll be described as monoids in the family of endofunctors, which is complex and useless. We're going to look at some examples of other things that we're familiar with in PHP and bring it back to comparing those things with monads to understand what the word monad means, how we use them, and to realize that maybe we've been using these things throughout our code bases. We just didn't know what they were called or why they were useful. So, also, this is a high audience participation talk, I think. I have a question for you, and I'd like some brave person to volunteer an answer for this. What is a stack? How would you describe a stack? Yes?
That allows you to add elements to it, and when you remove elements from it, they remove to the top, like a first in, first out.
I should have actually just brought the mic for you to say this into the mic, because it's a pretty good description.
Okay, so stack is a data structure that allows you to add stuff to it, and then you can pop stuff out so they come up from the top when you think.
Excellent. And for bonus points, how many values of the structure can you look at one time? Just one, the top one. That's a very good description of what a stack is. It's the description I'm happy to use in the talk, so thank you. A stack is a thing that has operations and rules. It's very well defined in many languages, and it differs from language to language. But when you get to a stack in a programming language, particularly as we're going to look at in PHP, it has certain operations and rules that you can depend on. Here's an example of the kinds of operations I would expect to see in a stack, even one in PHP. A way that you can make a stack object and you can push a value onto it. First in, first out, as you so helpfully said. But we're going to go for an immutable variant of this. So when you push a value onto it, what you get is a new stack. But still, you get a stack out of it. You can pop a value off the top of the stack. You can see what the top value is and no other value in the stack. And if there are no items in it, isEmpty should return true. If there are items, isEmpty should return false. Not particularly complex operations, but they define quite well how we can use the stack. There are some rules that apply to this as well, and if a stack didn't adhere to these rules, I would be hesitant to use it. The first is that when you push a value onto it, the top value that you see should be that exact same value. And when you push a value on and you pop it off, what you should have is the stack that you had before you pushed the value on it to begin with. If you push anything onto it, it shouldn't be empty, but if you've just made it, it should be empty. These are kinds of predictable rules that a stack could adhere to. This is kind of like defining an interface. And knowing the operations and the rules, we can implement these however we like. We could, for example, implement this, which I've called an ArrayStack. It has an internal store of values. It has a constructor that accepts and stores those values. And then we start defining the operations on the stack. Because I've got that immutable sort of slant that I want to give it, I create a clone, and I store the value on the clone's internal values property and return the clone. I do something predictably similar with pop, and the PHP array push and array pop functions are quite helpful in this instance. Top just checks if there are any values to return, and if there are, it returns the top one. And empty checks if there are any values. So this isn't a particularly difficult implementation, but it's one that adheres to the same operations and rules as we've seen a stack should have. We can create an object of it, push a few values on, remembering that it's an immutable-like thing, and so we assign the value because that's a new stack. But that's not really an important thing to what we're looking at. We can show what the top value is. We can show if it's empty. And we can even look at what the structure is once we've popped the value off of it. Let's run this and see if those values match up with our expectation. OK. We created the stack. We pushed 1 onto it. We pushed 2 onto it. Down here, we want to look at what the top value is. Hands up if you can think of what that top value should be, based on what you know. Yes? Anyone? Shout out. 2, yes. Which is what we see here. OK. That makes sense to us. Should it be empty? Nope. And though we've popped a value off, what we should get back is a new stack that has whatever the stack was minus one of the values that we pushed on last, which is what we see here. We have a stack, and it just has that value of 1 in it because we popped 2 off, and then we printed out what we had. So OK, it adheres to the operations and the rules. But it's our own implementation. We've implemented it how we feel like. Here's a different implementation. And this I've gone ahead and called LinkedListStack. Now, a linked list, if you're unfamiliar, is just something that tracks 2 important bits of data, the top value and all the other values in a list. So we can create it by giving that top value and the remaining values. We can push just by creating a new instance of this linked list stack. Take the old instance and put it in that remaining list of values and put the new value at the head. Does that make sense? I don't see any nods. I don't see any shakes, though. So if you have questions, put your hand up and ask, by all means. Pop just fetches the tail stuff. It ignores what's in the head. Top shows the head. I mean, this is and empty is if there is anything in the tail. And if you look at this example long enough, it starts to make sense to you once you understand what a linked list is supposed to work, how a linked list is supposed to work like. But it remains a stack. And if we use it in exactly the same way as what we used the ArrayStack with, and we run this code, we see the values that we expect to see. The last pushed value was 2. It's not empty. And when we pop a value off, what we should have is just the value that we pushed first, which is 1. The internal structure of this is different, and that's because the implementation is different. But the values we care about, the things we care about, should I say, are the operations and the rules. Are they being followed? So this is a stack, just like our ArrayStack was. We can define more operations because of the common behavior that we've implemented in both stacks. What if we wanted to add a size method to both of these implementations? Because we know that they have isEmpty and pop, we can use this behavior to recursively determine the size by counting how many things we can pop off of it until it's empty. And here we don't need to know what the implementation of ArrayStack or LinkedListStack is. We know they have the methods. We can use those shared methods, and we can build more functionality on top of this. So if we use this trait, the stuff will execute as we expect. It'll give the same result using the same methods, not caring about the implementation. And in this way, stack for us is a specification. It's like an interface. Our implementations implement this common interface, the 4 methods that we need, and they thereby give shared functionality on top of which we can build to extend our implementations. OK, different question. Let me just get my timer back up. What is a collection? Anyone want to volunteer a definition for this? And this one's, I'll give you a hint, a lot simpler and a lot more open to interpretation. What, if you were making a collection, would you want it to do? OK, store items to be of the same type. I don't know so much about a typed collection in the example I'm going to show you, but that's a really good use for it. There was a hand over there.
I can put stuff in it, I can take stuff out.
OK, but even simpler than that. There's a simple operation that I want to do with this. I'll show you what it is, because it's kind of a trick question, because collections differ very much from language to language. But the one operation that I want to have here, of the operations and rules we expect an abstract data type to have, is that I want to be able to somehow have values in that collection, and for each value in it, I want to be able to execute a function, so that that function gets the value for the iteration that I'm in. The operation is that this collection needs to have an each method, and I need to be able to give that a function that gets called for each value. And the rule is that that function gets called 0 or more times, because the collection could be empty, but that it's called in sequence, and it's given a value each time it's called. Okay, maybe not a universal definition of the operations and rules of a collection in every language, but one that matters for the example I'm going to show you. So, could we implement this multiple ways as well? Yes, we can. I'll start off with an array collection. This takes an array of input parameters and assigns it to another private store. And then it has an each function that will loop over each of the values within that private store and give it to the each function that I've provided. So we can create a new array collection object, and for each value inside it, we can print out what that value is. When we run this, we should see 1 and 2 and 3. And there, we see them. We can modify this a little bit just to make sure that we're not cheating. Run it again. Now we should see 1, 2, 3, 4, and 5. We have our array collection, and it adheres to the operations and the rules that I've defined that I want my collections to have. So I've, in essence, defined another specification that is collection, and I've implemented it one time. One time. Let's do another one, a range collection. So this one's a little more complex. We take a starting value, we have a step or an interval, and we take an ending value. I've called them this just to trick the syntax highlighting of this editor, but actually you can call them whatever you want. The start, interval, an end, or after, step, and before. And the each function here says, OK, you've got a start value, so let's add the step to it. And if that value is still before or no greater than the value that we need to end at, run the function with the value. And remember, modify the value for the next iteration of the loop, so that when we get back to this while section, when we've gotten to the end of the values we want to loop over, we stop executing. It's a slightly more obscure implementation of a collection, but because it has this each method, and because that accepts a function to map over each of the values or to execute on each of the values, it still has the same operations and rules. We define it in a very similar way, we use it in a very similar way, and when we execute it, we see the values we expect. Given that we now have two different implementations of a collection, we can extend them, knowing what behavior they already have. So let's say we wanted to be able to provide a function that we could execute on each value to filter out only the values that we want. In Ruby, this is called each, but in PHP land, it's array filter. You can think of it like that. So knowing that we have this each function, we can have an array to store the values we want filtered out, run the function provided to select on each of those values, and if they pass, add them to the result that we return at the end. It's a little easier to see how we use this in practice. We can add that method back to our different collection implementations, like here I've added it to ArrayCollection and to RangeCollection. And when it comes time to using this, we still define our ArrayCollection in the same way, but now we can use the select function. Notice these are exactly the same. And that's because our select function doesn't actually need to know about the implementation. It just uses what it knows the implementations have. So when we execute this, we should see 1 and 3 and 5 for both of them. That's interesting. I think that's interesting. An experiment in polymorphism, at least. Collection is a specification as we've defined it. Our implementations implement a common interface, and because they both have an each function, we can build shared functionality on top of them without knowing what the implementations are doing. So what are a collection and a stack? I've already said this name for them before in the talk as a hint. But what are they? Suggestions? Anyone? Yes. Data structures, abstract data types. That was the wording I was hoping someone would use. Doesn't matter. They are data structures or abstract data types. We can think of them in ways similar to how we think of strings and booleans. If we had a language that supported multiple implementations of Boolean, as long as it did what we expected from a Boolean, we wouldn't care what implementation it was using. So what does this have to do with monads? Let's refactor some code, because I want to show you how we get to using monads after this little bit of a warm-up that we've had now. How often have you had to handle the infamous null in your code? Say we had 3 value objects like this, and they had a relationship between them. Address had a string of city, and an address could be assigned to a store, and a store could be assigned to a brand, assuming the brand only has one store in this scenario. Well, we may create the relationships something like this. We have a city that belongs to an address, that belongs to a store, that belongs to a brand. And if we had a brand variable and we wanted to get the city, we could make a naive function like this. Hands up if you've seen code similar to this. Yes. There are many rules that this breaks, including ones that have funny names like the law of Demeter or however else I can pronounce it to frustrate you. But the biggest problem with this is that each step in here assumes that the value that has a property lookup is not null. So although I'm suppressing warnings in this output, if I commented this out, I would break the relationship between brand and store. And by the time it gets here, this will be null. And so looking up address on that doesn't really make sense. OK, so we've encountered this problem before. The obvious, though verbose solution is to say something like if brand and if brand store and if brand, I want to do all of this code so that you feel this pain. Brand, store, address. I'm going to do all of this. How does it feel? Brand. Actually, we don't even need to return that third level. We can just do return brand, store, address, city. This is a safer approach to what we had before. But it is a pain. It's a sideways pyramid. It's stupid code. We could concatenate these with using ampersands, and that would sort of sort out the problem, but it's still a problem we don't want to have to deal with. Though, if we execute this, it'll return what we expect it to return, I hope. Yes, there we go. It's still horrible code to have to write. So how could we refactor this so that we don't have to write that horrible code? Here is where it gets tricky, because our code's going to get a lot more before it gets a lot less. I suggest we could make something like a maybe monad. Forget about what this does specifically, because we'll come back to its particular structure. But for the purposes of the example, let me tell you what it's doing. We create a new object of this by giving it a value. If that value that we give it is already a maybe, well, we want to unwrap that. We do that by using the value function, which we define down here. OK. Then we need a way to be able to statically create this, just so that we can chain things a little bit easier. And I want to have a kind of implicit null checking in this, so that when I reach into it for a property like city, if I reach into, how do I describe this? If I reach into a store trying to get the city property out, I want to first be sure that the store address exists, which is essentially what this null check will do. We still have the same value objects. We still create the same relationships. But now we can try this bit of verbose code, and it should be less prone to errors. Let's run it and see. OK. We still get the value out. Hands up if you'd like to write code like this. No, I wouldn't either. OK. Well, let's refactor it a little bit to make our lives easier. For a start, what we could do is that this try method, instead of just returning a value, could return another maybe wrapped around that value. So if the value is null, we can chain on it. Something like static create. And if there is no value, we still want to avoid null reference exceptions, so we'll just return an empty maybe if there's no value which to inspect here. OK. Now, though this should still work, I'd rather want to take these out. So what happens when we do this? When we run it, I'm hoping we're going to see the value we expect. OK. It's a little bit better. Of course, we don't need to do this assignment anymore, because now that we have chaining, instead of doing all this mess, I actually want to copy it before I comment it out. Instead of doing all this mess, we can rather return right from here, and we can call try as we might. Right at the end, we can call value just to unbox it. Let's take that out, and let's do some indentation. Now I'm hoping this works a lot better than what we had before. Yes, it still works. We can chain it. Looks a bit better, but I'm still not happy with it. Hands up if you'd prefer to type this than the previous version. Yeah, we're getting better all the time. I don't want to use the string to look up the property. I'd rather get the object if it's not null and look up the property myself. Then I can start doing computations on that and transformations on it. So instead of taking a string property, I'm going to change this to taking a function. And instead of just returning that value, I'm going to return the result of the function, and I'll do the property lookup inside the function. So now, instead of calling try with a string, we'll call it with, I'm going to use short closures for this as well. Ask me about this afterwards if you're interested how I do this, but it maps to ordinary PHP functions. OK, we are looking up brand store. And if we have a store, then what we want to do is return the store address. And if we have a store address, well, then what we want to do is return an address city. OK. That seems fair enough. And then we can just dereference it at the end. So let's run this, and hopefully it works. Yes, it does. It works. OK. That's less code than before. Granted, you're probably going to have the longer functions here if you don't decide to be smart and use preprocessors, but that's a discussion for a different day. Let's just make sure it works. I use this elsewhere, so it's important for me to introduce it to you now. OK. So this works, but now our try method isn't doing exactly what it was doing before. I want a better name for this, something that describes what I'm doing. And I'll do that just as soon as I see how much time I have left. Lots of time. Right. This is no longer just trying to get the property if I have a value. Now it is saying, if I have a value, then run this function and wrap the result in a new instance of maybe. So I'm going to rename this to then. And you'll see why that makes sense later on, but I know for now. Right, then. Let's just rename these quickly and make sure they're still working 100%. OK, 2 more quick optimizations I'll do to this maybe class. This is still verbose. I could shortcut this a little bit. One way to do that is to make the values available through a method call instead of using then with a closure. If I were to say something like public function call, and actually spell it right, I guess, method parameters to fulfill the interface requirements. OK. Then I could return this then with a function and the value that's being returned if it's not null. Just make sure I'm doing this correctly. Return this method. This, sorry, value method. Well, I mean, it's kind of deceptive because, as you'll see, I'm actually, ooh, I have an error. Let me see, line 46, around line 46. You are right, I do have to, thank you. I misunderstood, thank you. Yes, right there, thank you. I think this will work. Yes, it does. Okay. Oh, well, I mean, we're not really doing anything special here. But now we could replace this with something like address. And we could replace this with something like city. Let me execute this and see if it works before I explain why we can do that. Yes, it does. Okay. Now, instead of calling then with a function that does the lookup, which is what we wanted, we still have that functionality to use if we need it. But as a shortcut, we could say, OK, if I know the name of the property I want to look at, I don't want to have to type a then, even though I have the ability to still do that. I would rather call a method and have that proxy to an implicit then call. It's just a bit of syntactic sugar. This is another reason why I use short closures, by the way, which I'll repeat. I'd love to talk to you about at some point. But that would still work if I used short closures there. OK. I want to take this one step further, quickly. Get. And for this, I will just return this property. And I'll not make these as methods, but I will unbox them right at the end. Yes? There's a lot of magic going on there, right? There's a lot of magic going on there. The fact that we have to wrap this value and unwrap it is symptomatic of a system that doesn't understand the concept of maybe yet. But if you build your code inside of your application framework that passes around maybes instead of absolute values, if you had something where you did this type hinting, then instead of calling this directly, you would move this bit of nonsense down here, and you would unbox it here, or in a larger system, you would just continue to pass around maybe instances. However, if we reduce this, oh, I need the semicolon there. Silly me. If we reduce this, I'm assuming our code will still work. No, what have I done? Let's see, can anyone spot what I've done wrong? Like that? Yes. Instance of maybe, instance of brand given. Oh, yes. I see what I'm doing. I see what I'm doing there. OK, we decorate the brand. We pass that to the getCityFromBrand function, and we unwrap the value on the outside. OK, so we get our resulting value. We still have our naive implementation here. And I can delete this other mess here. Because now we've started to introduce the concept of maybe to the wider system. We accept potentially null values, and we emit potentially null values. And our system wraps and unwraps at the beginning and the end of the request. But now we can deal with these values a lot simpler. And we have our nice and clean naive implementation that is implicitly null checking. We can remove the relationships, and it's still going to be null at the end, but we're not going to get the warnings that we would get from a null lookup error. I say that, but apparently I've made an error elsewhere. Fine. This is the point, though. We've gone back from a naive implementation to a very verbose implementation of using maybe back down to a simplified version again, as long as our system is able to give us maybes and take maybes out of it again. That was a long refactoring. The next one's going to be a little bit simpler because for reasons of time, I'd not like to repeat a lot of this stuff. But what if we had this situation? What if we worked for, I can't think of a funny name, variation of WordPress, but what if we worked for a blogging company and we needed to start making tag clouds for our blogs? We could have any number of blog objects like my blog and your blog and your blog. And we could have any number of categories belonging to those, and any number of posts belonging to those, any number of posts belonging to those, and an array of comments inside that. So to set that kind of relationship up, there's a lot of messy code over here. But you get the idea. We have blogs, in there we have categories, and then we have posts, and then we have comments. There's a lot of nesting going on here. To make our tag cloud, we would have to reach all the way from the top list of blogs down to each list of comments, split them up by white space, and then return a merged list at the end. That's a lot of repeated work we would have to do. I've made a utility function. You don't really have to understand exactly how that mess of code works, but basically it takes lists, it goes through each of them and applies a function to the children of that. It's called flatmap, and it's quite common in other languages. And even in some frameworks like Laravel, there are methods for this kind of thing. OK, we could make our function to get comment words for a blog. We could loop over all the categories, and for each category, loop over all the posts, and for each post, loop over all the comments, and for each comment, split it by white space. And because we're using this magical flat map method, what we get at the end will be an array of all the individual comment words combined. Let me run this so I can make sure it works before I explain further. OK, it's doing that. It's the kind of comment words we can expect from modern comment sections on the internet. And it's doing its job. It's going through each blog and each category and each post and each comment and splitting them up. And we just get a neat array at the end. However, this, hands up if you'd like to write code like this. OK, we can make it better, though. Not nearly as much hackery as before. Same objects, same relationships. But let's make a new kind of monad called many. This looks very familiar. We store the values in an internal property. This looks familiar because we're just creating a new instance of it to allow chaining. This looks a little bit different. We'll talk about that now. But this looks very familiar. The only thing that's different here is that the then function now runs flatmap with that function that we want to execute on each value. We have the same merging method, but now we can do this. Ha! That's pretty cool. Apparently, my auto-completion stopped right at the end. I'll just copy this quickly so we can execute it and see that it still works. Yes, so when we run that, there we go. It's still working. It's not doing the nested flat maps anymore. Now it has a similar then method to what our monads had. We can apply the same underscore call and underscore get shortcuts as we had before. And what we would get at the end is a way to say blog, categories, posts, comment, and give comment, just comment, a then call, so that we can split by white space in it. So this is a very similar structure, wouldn't you say, to what we had with maybe. So why are we doing this? Why are we making maybe, and why are we making many? They are similar things, as we've seen. They both have a then function. They both have a create function. So we can make an object out of some values, and we can call a function against them. We do this for maybe. We do this for many. And as I've said, they're monads, but what does that actually mean? Well, right in the beginning, I said that monads are an abstract data type. And we saw some other kinds of data types. And now that we've looked at monads, there should be some similarities linking up in your mind. Monads have operations and rules, though we've seen them in code. Let's go over them again. The operations are that we have a then function, a way to pass a function into the monad and do something with it. And we have a create function, so a way to make a new instance of the monad based on some input parameters. They have rules that we've seen as well. When then is called, it needs to call the function we provide 0 or more times because maybe the monad's empty, or maybe it's null value inside. It always returns an instance of the same monad. When we had maybe, and we called then on it, we got back a maybe, whether or not it had a value or null in it. When we had many, we called then and we got back, we called then and we got back a many, whether or not it had anything in it. And when we call create, it shouldn't interfere with that value either. What we've done is we've made a specification. We've implemented a common interface for both maybe and many, then and create. And that's allowed us to have some shared functionality across them. And this is the most interesting part. Because we can now use then to connect multiple operations from multiple kinds of monads, and they'll just work. But let's unpack that statement a bit. What then does on maybe is that it will always do the next thing if the value is not null. On many, it will always do the next thing for each value. And we can use this knowledge to build on top of our data structure. Imagine we wanted a within method, something that would call a function on a value, similarly to what we're doing with many, but if it's just one value, if it's not a collection kind of monad, we still want to execute that function on the value. We can define it like this, which may not make a lot of sense to you now, but when we add that trait to maybe, and we add that trait to many, then we can create our new instances of maybe and many monads in a way that makes sense for that monad. This shouldn't be maybe, this should be many. We can create our instances of maybe and many in a way that makes sense to each of them. However, we can call them with exactly the same function. There's missing a bracket there as well. We can call them with exactly the same function, and that means different things to them. On a maybe, it will do a lookup of this value if it's not null and convert the key that we're referencing there to uppercase. So we get uppercase Chris. Look at how this is defined. So this function makes sense. And in this case, the result is the uppercase of whatever that value is. And in the instance of many, we can use exactly the same function here, exactly the same behavior in here. But because of how many works with then, it will be executed on everything inside the many. That's, I think, is the most interesting thing about all of this, is that we can now extend maybe and many in the same way as what we extended ArrayStack and LinkedListStack. And we're already using these ideas anyway. Whether or not we're extending maybes and manys out in the wild, we're using monads every day. Who of you have used promises in JavaScript? Very many of you. They work similarly to this. In JavaScript, there's this new fetch method. If you did Ajax back in the day, this is a nice replacement for that. It's a promise-based HTTP request function. This is the simplest use of it, but we can tack then on the end of it. So when we call fetch, we get back a promise, and when that resolves to a value, when the request is completed, this short array function here, or the short arrow function here, gets executed. We get back the response, and we can say, okay, well, return the JSON of that response. That is another promise-making function. So we can tack another then on and say, when you've got the JSON data, render something with it. This then stuff is what we're familiar with, looking at maybe and many. But it's a different kind of monad called eventually, or promises, as it's commonly known. Hands up if you use jQuery. I know you have. Come on, all of you have. You're PHP developers. jQuery has a very similar concept. It doesn't have the same method names, but the idea is there. With jQuery, you can use a CSS selector to fetch something out of the DOM, make a reference to it. You can filter infinitely on that. And if you filter to a point where no elements are matched, you still get back this magical jQuery object that you can still use function calls on. So it's doing null checking with filter. It's also doing null checking with the modifications that you can do to the list of objects wrapped inside that special jQuery object. So you can add events to them, and you can change their CSS, and you can animate them. But every time you call a filtration method or a modification method on that special jQuery object we make right at the top there, it gives back another special jQuery object. And no matter how few or how many return DOM elements there are, the functions will always work. There are exceptions that I think are being phased out in jQuery, not that I've looked there in quite a while, but there are exceptions where functions will not return the magical jQuery object. Most of them do, and that's the important thing with working with jQuery. Hands up if you have used or are using Laravel. Quite a few of you. Good on you. Laravel has a query builder and an ORM called Eloquent. And the way that you filter down to records in a database looks something like this. This is just using the query builder. It's not using an Eloquent model. But we target a table, and then we start to construct where clauses on that. Call where and or where, and you can give it a naive set of values to do a simple comparison, or you can give it a closure and it'll do a subselect sometimes, and that's using a very similar concept to what we saw in jQuery, where no matter how many times you call where and or where, or any of the other query builder methods, you're still going to get back a query builder. Whether or not your query makes sense, it could execute and never return anything, but it's still going to allow you to continue to call methods on it. And what you should be seeing now is that monads are good for repeated operations. In maybe, the repeated operation is null checking. In many, it's a repeat of flat mapping. In promises, what you do repeatedly is you give closures to be executed when the promise is resolved. And you can then, and it'll be fine. In jQuery, the repeated operation is to filter and modify elements from the DOM. In Eloquent, it's to repeatedly modify a query. And these are all things that you've been using. Maybe not the first two, but the last three, certainly. So when you see yourself making repeated operations, think of how you could be using monad-like things instead. Is there a way that you can refactor a lot of behavior that you repeat, not code, but behavior you repeat, in such a way that it would work well as a then function? Try to use monads. I've shown you two new ones. There are a plethora of them, but now I hope you have perhaps a greater understanding of how and why. And then tell your friends about them, because I think they're not the kind of thing that we should be whispering to each other about and avoiding like the plague. I think there's a case for them to be seen as just ordinary abstract data types like what we're used to. I think that's all I have. So thank you very much for being here.